Hi there guys, and welcome to this video on solving trig equations, but this time not in degrees but in radians. Now we're going to start off with looking at some of the graphs. I'm never actually going to solve using the graphs, but I think it's a nice place to start. So produce a sketch of sine 2x. Now it doesn't say in radians, but you can clearly see here, any mention of pi, it's radians. But can you see this little c here? Normally have a little O for degrees, but when it's a c, a little bit of the O missing, that is a symbol we use for radians. Why didn't we use r? I don't know the answer to that, but we use c. But you don't often see it actually, they just write in terms of pi, so then you know it's radians. But you just need to remember that 2 pi radians is equal to 360 degrees. So, to draw any sort of transformation, I would always start with excuse me, sine x. So here's my simple sine curve, up to 1 and down to -1, and that's going to be 2 pi, this is going to be pi. So if I do that again, and just think about what the transformation is. Okay, look, it looks like the x is being times by 2, doesn't it? Beware of the brackets. Anytime it's a bracket, it's always the inverse of what it actually looks like. So x is not being times by 2, it's actually being halved. So every single x value on here, these are the easy ones, they are being halved. This one's being halved, this one's being halved, even all of these are being halved. So let's just draw the first one for a minute, but because we're going all the way to 2 pi, actually I am going to draw a second one just to see if I can elongate this x-axis. Yeah, I can. Okay. Right. It's still going to go up to 1 and down to -1, and you can see I've tried my best to make sure that these are both level. That's really important. If it's obviously different, you're going to lose marks for it. There's nothing stopping you getting a ruler, drawing a faint line across to try and hit it. But if we take this point here is 2 pi, it's now going to be halved, so it's going to be pi radians. And this one is also going to be halved, so this is pi over 2. So this would be 2 pi, normally 4 pi, and so that's 1, that's 2, this is 1.5, so 3 pi over 2. It's only really important to mark on a graph where it crosses the x-axis, so that's what I would do. Okay, so hopefully that has made sense. Now we've got this hence. Okay, that's normally to use the graph, or to use what you've just done to solve this problem. So here's -1/2. Okay, we should be using this one, so I'm going to just change colour. So if we go across at -1/2, you should see this 1, 2, 3, 4 results. Okay. But I'm just not a fan of it, so I'm going to use the cast diagram. So have I got a blank one? No, but there it is there as well, just a more accurate and pretty looking version of mine. So let's just go ahead and solve this using the cast diagram, because that's what we normally use, so let's do that. Right, so C-A-S-T. We know sine of the values is negative. So sine values are negative in these two quadrants down here, and we're interested in what these acute angles are. We've got to be careful. Whenever there's a range change, we're going to account for the new range. So 2x is going to be inclusive of up to 4 pi, but the 0 is unaffected. Okay, so that's just, we have to make sure we go all the way up. And when we look at the graphs, that's it's going to get us those 4 answers, because we're going to half it afterwards. So there we go. All right, that will make a little bit more sense in a minute. Okay. So, what does 2x equal? Let's find this angle. So make sure our calculator's in radians. So you have to go to the setup. So that's shift and then the menu button. Mine's written in yellow at the very top. Angle unit, we're going to change that to radians. Make sure there's a little r at the top of your calculator. So we go the inverse sine of -1/2, and that is pi over 6. So it's a pi over 6 in there, and a pi over 6 in there. My calculator actually gives me -pi over 6 and you can see that in the negative direction that is that. And we spoke about that in so many videos prior to this, so hopefully you're happy with why I've not written the minus. Okay, so we've got to go on our journey between 0 and 4 pi. So here's 0, here's pi, here's 2 pi, and this one's obviously going to be 3 pi as well. Oh, you can't even see that over there, can you? 3 pi, and then we get back to 4 pi. So we have to keep going round twice, basically. Right, so we've got pi plus 1/6. So we've got 1 and 1/6, which is 7 pi over 6. Keep going round, we've got 1/6 shy of 2. So that's 11 pi over 6. 2 being 12 over 6. Okay, so now we're at 3 pi. So we've got 3 plus 1/6. That's 19 pi over 6. Now we've got 4 pi, take away 1/6. So we're going to have 3 and 5/6. So what's that? 23 pi over 6. But that's what 2x's are. So what we have to do now is to divide everything by 2. And when you divide by 2, it's the same as times it by a half. So all I have to do is change all these denominators to a 12. So 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. So you can see it's well within our range of 0 to 2 pi. They're the 4 results that we would have got from our graph 1, 2, 3, and 4. I just much prefer the cast diagram than the graphs. So I'm not going to bother with this bit, but just do, you could have a go at drawing these for your own benefit, and then maybe use Desmos to check them, and just change the unit measure to radians. Okay, but we can just talk briefly. So this is a cosine graph, but all the x values are divided by 2. A sine graph, all the x values are divided by 3. A tangent graph, but all the x values are multiplied by 2. Alright, I did prepare the answers there. Okay, so we get into the better questions now, just straight up solving, and then we'll start looking at some identities. So anytime I see a trig equation, cast diagram. The cosine ratio is positive here, so there and there, all are positive, cosine is positive. And we're in radians, so don't start putting 60s in there, that would be silly. So shift cos 0.5. And we get a pretty disgusting number to use, so which is 0. I'm just going to go for 0.88 in here. This is a straightforward one, there's no range change at all. So we're going to have one solution and two solutions. Okay, so x is going to equal 0.88. I could put a little c there for radians. And 2 pi minus that as well, so I'm just going to type that in. So 2 pi minus my answer, and I get 5.41. Okay, so two solutions for that one. That's it. So it's exactly the same as working in degrees, but it's just in radians, so just make sure your calculator's in the right mode and just do it exactly the same. Instead of typing 360, you just type in 2 pi. This one's way better because you start, oh no, I thought I had to use some identities, but looking at this it's pretty simple, but it has no solutions. So hopefully when you're thinking about this, discriminant pops into your head. We may not need that. Let's see how it goes. It may just be one of those questions that you just have no solutions for, and I'll explain that in a minute. So any equation that's not linear, everything has to be on one side. So let's start off by doing that. So I'm minus 12 to both sides. Okay, and then it's a quadratic, so we're going to have to factorize. 2's a prime, so I'm just going to go straight in. You can, if you want to, say let sine x equal y and just make it a bit more user friendly, but let's just go for it. Okay, so 12 has lots of factor pairs, but if we go for the 3 and the 4. Yeah, this one works. After a while you can do these pretty quickly, but I can see that 8 take away 3 is 5, and the signs are different, which they need to be to make them negative. Right, so hopefully you've started to see it maybe, but that has no solutions, this bracket here, because the sign ratio only goes up to a maximum of 1, and this one will also have no solutions because the sign ratio only goes down to -1. Okay, so just therefore no solutions. It was as simple as that. Very rare that that happens. Normally there may be, well, on occasion there could be one that doesn't work, on occasions there could be 2 and you have 2 cast diagrams or just the one. In this instance there were none. If they didn't tell you you've got no solutions, at this stage you'd panic probably and think, oh crikey, I've gone wrong, but you're expecting it to not work. Let's just see one that does work. Right, this is a much better question. So we've got 2 different ratios. We can't have that, so we have to use an identity, and we use the identity that tan of an angle is identically equal to the sine of the angle over the cosine of the angle. So if we divide everything by cos 2x, I have to keep the angle the same, okay? Otherwise the identity won't be true. The cos 2x and the cos 2x, they're going to cancel each other out. So it's just going to leave me with 3 on the right, and this will be tan 2x. So we've got a single trig ratio, we're ready to go. If you're worried about this being higher than 1, it doesn't matter when it's tan, it's the only ratio that you can have any number you want there. So, cast diagram, CAST. The tan ratio is positive, so it's positive here and here. We've got to find and specify this new range, so we're going to be looking up to 4 pi, greater than 0 but inclusive of 2 pi, so it's greater than 0 but inclusive of 4 pi. So we're going to have to go around twice, so it's always good to write these on, just especially when you're new. So this is going to be pi, and this is going to be 3 pi. Okay, so let's do the inverse tan of 3. So shift tan 3. Oops, something funny going on my calculator. So it's 1.25. I'm going to pop that in there. 1.25. Okay, so the first one, it's a pretty simple one. So 2x's is equal to 1.25. Now we've got pi plus 1.25, so I'm just going to I'm actually going to just store that as a, because I'm storing the 1.24904 as a. Okay, just going to be using that often. So I've got my answer, but this time I'm plussing a pi. That's to give me this solution here, which I get 4.39. Then we've got 2 pi plus this one. So I'm going to go for my answer again, plus this time 2 pi. And that gives me 7.53. I have to go into another line. This time we've got 3 pi plus my answer, so 3 pi plus a, and I get 10.67. So now I just have to divide by 2 just to get it back down to the range that we want to. So let's just type these in. So I've got 0.625, so 4.39 divided by 2, 2.195. You could round these to 2 dp if you, 1 dp if you'd like, because they're angles. That's pretty common to do that. So let's do that now. So we've got 3.8. So let's just get rid of that one, change that one to a 2, get rid of that. And 10.67 divided by 2. And you get 5.3. And if you want to, you can put a little c there, but it's not completely necessary. Right, solving radians, the same as solving with degrees, we just change the mode of your calculator. That's it. Best of luck everyone.